All right, so welcome back, everyone. Hope you had a good 3-day weekend there with Labor Day. I want to pick up where we left off with finishing up with some conditionals. And then by the end of the day, of course, as soon as we're done with that, we'll go on to the next topic, which is loops. So at the very end last time, we presented some pitfalls, right? So I asked you to consider the following piece of C code. Now over here in the CS50 IDE, when I have this code, first of all, it's got to be, it's not looking too good, right? So let's go ahead and go in and fix it. What's that command line tool in the CS50 IDE that I can clean up code and make it look better? A style, right? And this is just demo. Right, so I'll go ahead and clean that up, and now it follows proper indentation. Now when I compile this, right, and I ran it, right, now is it going to print out foo or not? Because zero, I mean the intention here is between, if A is between 0 and 10 inclusive on both ends. So of course, yes, it's going to print out foo because 5 is between those two, right? But as we observed last time, if it's something outside of that range, it still will print out foo, right? If it's something on the other side, 15, right? It's printing out the wrong thing. It compiles, it runs, it just doesn't give me the results that I intended, right? And so there's a problem here. Now, when we cut and pasted that old that same code over here into Eclipse, it won't even compile, right? And the error here is, if you can see, the operator less than or equal to is undefined for the argument's Boolean int, right? So we'll talk about what that means here in a second. Yeah?
What was that shortcut you used?
Oh, to clean it up in Eclipse?
Yeah.
Well, I'm on a Mac here, so it was Shift Command F for format. I imagine on Windows it would be Shift Alt F. I don't know. Your mileage may vary. You'd have to look that up, right? But otherwise, it won't even compile here, right? Now, what the problem is that you can't use a compound statement like this. You have to break it up. So let's walk through and see what's going on here. So 15, is 0 less than or equal to 15? Yes. So what is in C, what's true and what's false? What's false, first of all? 0. What's true? Anything else. But the usual placeholder is 1. So that evaluates to 1. Now we're no longer talking about A at all. 1 is less than or equal to 10. Is that true or false? That's going to be true. If this evaluates to false instead, it will still be true, right? And so that's what's going on under the hood in C, okay? Let me go ahead and restore it over here. And you're not even allowed to do something like that over here in Java. The compiler is able to catch something like this and say, no, you can't even do that, right? So what's the fix here? I need to check both ends. If A is greater than or equal to 0, and A is less than or equal to 10. Now, when I break those up into two statements, it is perfectly fine now. Well, in C, of course, I'll get the behavior that I want. It no longer prints foo on either end. And when I take this over to Java, now the compiler is happy about doing this, okay? So you need to split it up into compound statements, into using, what is this, what was this thing called again? Ampersand, ampersand is the logical, what kind of a logical operator though? And, the logical and operator, right? So again, the above code in C compiles and runs, but does not give you the intended results, right? Instead, the solution is to, or in Java, it won't even compile, right? So the solution is to use the logical and operator. And for that, here I'll put in the correct code. There we go. There. Okay. That's correct in both languages, except, of course, for the print statement. The printf, it would be system.out.printf. All right. So here's another pitfall. Again, consider in C the following code. Right? Int A is equal to 5. If A is equal to 10, then do something. Let's find out what happens over here in the CS50 IDE when we run this. Remember, we are online. If you have any questions, you can go ahead and post to Piazza, or you can go ahead and put in the chat. Right? The YouTube chat. Right? And let's just go ahead and A-style this. There we go. All right. Oh, okay, you already caught it, right? Good eye. But let's find out what happens. Ooh. Right. Yes, the problem here is what on line 13, is that an equality testing operation? No, it's an assignment operator. And C is perfectly happy to do this for you, right? Let's go ahead and compile it, right? Oops, I didn't, no, I put in A. What do you, oh, consider the following piece of code. Okay, yes, consider the following piece of code now. All right, let's go ahead and get rid of this. There we go. The compiler is perfectly happy with this. When it runs, what's it going to output? What do you think? 10? Oh, well, will it output foo or not? What should it do? My intention was if A is 10, then output foo, but A is not 10, it is 5. So it should not print anything, but it does, right? Now again, what's the problem here? A, I'm setting that equal to 10. So it takes on the value A at that point, which, as we've already set it equal to 10, is 10. And is 10 true or false? True, therefore it prints foo, okay? Now, can you even do something like this in Java? Let's find out. Nope. And again, system.out.printf. Right? There we go. It won't even compile anymore. With the same error message, I bet. Type mismatch. Cannot convert from int to Boolean. In Java, you have full Boolean types. Only Boolean types can be used in logical expressions. You can't use 0 for false. You can't use 1 for true. You have to use true and false in Java for true and false. Right? Those keywords. In fact, just prove it again. Prove it to you. Boolean is student. Right? In C, I would go 0 for false, 1 for true. This is not even going to compile in Java because you can't do that. You have true and false. You need to use them. True or false is the way to go there. All right. So what's my mistake here? Again, I need to use an equal sign. Equals equals is the appropriate operator. Right. So again, in C, the above compiles and runs, but does not give the expected results. Right? In Java, does not compile. Right? Because you need to use proper Boolean types. Right? The mistake is misusing the assignment operator. So how could I rewrite that so that it's correct? Well, just take what we had before and change it to equals equals. All right? Okay. Here's one last pitfall piece of code. There we go. Consider the following piece of code. All right, I've corrected my mistake. A is equal to 10. All right, A is 10. Is this going to compile? Is this going to run? Is it going to give the results that we expect? Oh, let me go to CS50 IDE over here first. There. So, A-style that. Right. So is that going to run or not? Well, is it going to compile and run? Let me go ahead and, it wants to use a different style of formatting there. So GCC demo. All right, it compiles. All right. Is it going to print A is 10 or not? Remember, A is 5. I corrected my mistake. On line 10, I'm now checking for equality. I'm not using the assignment operator anymore, right? So it probably should not print A as 10, but once again, it does. Why? What's my mistake here? Semicolon, right? What is the semicolon doing in this case? Remember that an if statement binds. In other words, the if statement is What do you want to do if this is true? I want to do this. That immediately follows the if statement. Now, under normal circumstances, that would be the opening curly bracket, closing curly bracket. But what I've done here is, let's go ahead and just look at this one statement in isolation here. If A is equal to 10, do the following statement. What is the following statement? Nothing. So, if A is 10, do nothing. And then move on and execute this code block, which has nothing to do with the if statement, because you already ended the if statements binding to an empty statement with the semicolon. Okay? So what's the problem? Oh, I'm misusing that semicolon. And hopefully it becomes abundantly clear that, well, that shouldn't be, it just looks wrong, right? Right? Once you look at enough loops, once you look at enough conditionals, once you look at enough code, you start seeing these things like, whoa, that's off. What's going on there, right? So again, what's going to happen over here in Java? Let me go ahead and get rid of that. And then system.out.println, let's say. Is this going to, so compiler's fine with this now, but I end up getting the same behavior. You are binding it to an empty statement, right? Okay. So the above will compile and run in both languages, but not give correct results. Right? The semicolon means that the if statement binds to an empty executable statement. And that makes sense in a computer that you can tell it to do nothing. Sometimes we call that a no-op or N-O-O-P, noop, no-op, no operation, don't do anything, right? Sometimes you need to be able to tell a computer to do that, or to do nothing, right? So here is a very nice tool, right? A linter. All of these problems, first of all, you can avoid them with more experience, right? That you see these problems immediately by just looking at the code and seeing, oh, there's something off there. Equals, that doesn't look right. But there's also another tool that can do this. Because a computer is nothing more than an automated piece of machinery, right? So your code, it makes sense that you could write a program to look at your code and compile it, right? That's what a compiler is. But it also makes sense that you can write code to look at your code and say, that doesn't look right to me, right? Yes, that's syntactically correct. Yes, that will compile. But is that really what you wanted to do, right? And this that's called static analysis. Before you compile a program that looks at your program and looks for potential problems, it's analyzing your program. So it's an analysis tool. It's called static analysis because it happens before you compile your program. And one such tool is called a linter. So what is lint? So think about your clothes, right? You take them out, you wash them, you put them in the dryer, you take them out of the dryer. Are they clean? Yes. But are they might still have some little pieces of lint on it, right? Leftover stuff. That doesn't mean that it's dirty. It just means that it has some lint that you might not want there. And that's what a linter tool is. It looks at code that is not necessarily wrong, but looks kind of fishy. It's clean code, but, did you really mean to leave that there, or did you mean to pick that piece of lint off and throw it away for you, right? Now, the tool that we're going to use is still GCC in the C programming language here. But let me go ahead and restore all of these pieces of bad code here, right? Let's go ahead and go with this. I'll put that in there. The other one was what? This. And I'll actually make it do something instead of ... because of course ... is not correct. C, right? And there we go. All three of these examples are now restored here. And let me go ahead and clean it up with A style. All right. So again, if I just compile this demo, the compiler is perfectly happy with this, right? It's syntactically correct. It is correct code, right? But clearly it's not correct code because it doesn't give us the results we want. The compiler is fine with it, but what if I turn on some warnings, right? This is the wall flag or the W all flag. Now a whole bunch of things come to light. Warnings, warnings, warnings everywhere. Warning, comparison of constant 10 with Boolean expression is always true. And the same line here is telling me comparisons like this do not have their mathematical meaning. This isn't math, this is code, right? Warning, suggests that parentheses around the assignment operator is a truth value here. There's something fishy about what's going on right here. Is that what you meant to do? Now, it's not going to read your mind and think, oh, they meant the equals sign, right? It's just going to give you a warning that there's something wrong right here that you probably didn't mean to do. You need to take another look at it and see if that's lint that you actually meant to be on your shirt or it's lint that you want to take off of your shirt. And finally, this is misleadingly indented as if it were a guard, right? So this last one right here, because it is bound to an empty statement. This if clause does not guard. It doesn't do anything, basically, right? So cryptic error messages here, but at least it's highlighting these problems, right? Now, what was the flag that I used to do this? It's the wall flag. It's not the wall like holding stuff up. It is the W warning, capital W warning, turn them all on because I want to know every single possible thing that's maybe wrong with my code. Now, a linting tool like this is not going to catch every single mistake. It's not going to catch bugs because, again, a computer does exactly what you tell it to do, right? But it can catch a lot of stuff, right? And it is a very nice tool to use. In Java, the compiler will sometimes give you warnings, like, for example, unused variables. Int foo is equal to, or I'll just go ahead and leave it like this, right? This is not a compiler error. It still compiles, it will still run. But it's giving me a warning, right? And that little symbol over there is a warning. The value of the local variable foo is not used, okay? That is a hint that you've got some lint there. Did you mean to leave that, right? Or is that cruft, right? It's junk that's left over from some other version of my program that you probably need to get rid of. So make sure that you're taking care of all of your warnings. Make sure that you're paying attention to all of your warnings because it can really save you a lot, right? For example, what if I use scanf, right? Scanf, I want to read in a double here. So double x, and then I will read in x, right? Now, if I didn't have the wall flag there, well, I guess it is by default now, it expects an argument of this type. Some configurations would not come up with this. X is used uninitialized in this function, and by the way, it looks fishy there. What did I forget as far as scanf goes? The ampersand right there, right? So it will really help you to save yourself from yourself. And by the way, the grader has all the warnings turned on in both languages, and you do need to address them all, right? That's part of your design rubric, okay? Okay, that's linting. Again, it's not necessarily dirt. It's not necessarily bad code. It's just stuff that will likely result in a bug or other errors, stuff that we don't want, that we want to pick off our shirt, or you want to use a linting tool. Usually you use a lint roller with real clothes, right, to get rid of the lint. It's a static analysis tool. Always use the WL flag from now on when you are compiling with C code, right? And to catch all those things, okay? Any questions so far? No? Okay. It doesn't matter how experienced you are, it is always still a best practice to make sure that you're turning on all those warnings because even the most experienced people can forget say a colon. And when you've got when you miss a colon, then it can go for years without being caught, and you have a go to fail kind of thing, go to fail bug in iOS, right? Because of one missing colon, Apple's operating system or some sort of a security library, there was an SSL bug that they missed a simple colon that told it to go to a fail message, And by leaving it out, omitting it, it was actually short-circuiting all the security, meaning that the security wasn't actually being checked. So there was a bug in there for many, many years because of one missing semicolon. And even a basic static analysis tool would have caught that, right? So keep that in mind. Speaking of short-circuiting, there is an idea of short-circuiting with logic, right? So consider the following logical AND statement, A and B, in either language, right? If A evaluates, and it could just be a Boolean expression, it could be a Boolean variable, or it could be an entire expression like A is less than or equal to 5 or something like that. Suppose that it evaluates to false, right? Does it matter what the truth value of B is? So remember, it's A and B. If it evaluates to false, false and who cares, right? Because the entire expression will now be false, right? So no, the value of B will not even be looked at by the program, right? It will simply skip it. It will short circuit it. The program will skip or short circuit the evaluation of B. Right? And this is for efficiency. Think back 50 years when CPU cycles were measured in literally, fractions of a second instead of nanoseconds, right? If you could skip out on some operations, you did it, right? So they wrote code, they wrote languages to have short-circuiting built in. If I know that this expression is going to evaluate to false, should I even, by looking at the first part of it, should I even bother wasting CPU cycles looking at the second part? No. So skip, move on, right? And that's what short-circuiting is. It's like an actual circuit. If you've got the circuit here, what is short-circuiting? Like, what does that refer to? Oh, no? Never played around with electricity? No? All right, here's a circuit, right? It's coming from a power source and back into it. You short it out by, here's the power source, here's the light bulb that it's powering. Well, it needs a circuit, right? It needs to go back and forth. The current runs this way. Short-circuiting means that you short-circuit out whatever you're trying to do. The light bulb goes out. And now the electricity is going around in this smaller circuit because electricity always tries to find the path of least resistance, like all power, right? That's why you put on lightning rods, right? You want the lightning to strike over there, not on your expensive home. So you've got lightning rods that follow the path of least resistance. So that's what short-circuiting is. It doesn't look at the second expression. Instead, it says that the first expression is false. So immediately, skip out on that second expression. You've never done that? You've never short-circuited a capacitor? And then sparks everywhere? Fun? No? Okay. All right. Fine. Have some fun sometime, right? So that's called short-circuiting. It also happens with the logical OR operator. So consider the logical OR operator. A or B. In this case, if A evaluates to true, does it matter what the value of B is? Nope. No. So it too is short-circuited and not evaluated. Again, you're thinking back 50 years ago when if you could skip a few CPU cycles, you absolutely did it because it made your programs noticeably faster, right? Seconds faster instead of just nanoseconds faster. Now, fast forward to today, short-circuiting is not really all that necessary for efficiency, but it's become to be expected in programming languages because that's how they did it back then. And so we like our programming languages to be familiar, and it still happens. Even with a brand new programming language, they're still going to have short-circuiting. There's only one or two languages that I'm familiar with that don't have short-circuiting like this. Every major language is going to have short-circuiting, okay? So it's not the same thing as the logical AND operator technically because it short circuits, right? So programmers expect this behavior, and it's what's called a programming idiom, right? So what is an idiom? Just in regular old language.
Turn of phrase.
Yeah, it's a colloquial term of phrase, right? Give me an example. Not to put you on the spot, but do you have an example?
Hot under the collar.
Oh, hot under the collar. Okay. Raining cats and dogs, right? It's a piece of cake. We all know what these things mean because it's part of our language. Even though if you look at them literally, piece of cake, it's a piece of delicious cake sitting there. Doesn't mean that something is easy. That's the colloquial meaning. That's the idiom of that expression. Every language has something like this, right? And if you try to directly translate it into another language, if you try to translate piece of cake into Chinese or Spanish or something like that, and they don't have that idiom, what the hell are you talking about, right? It's nonsense because it's a metaphor. In programming, we also have idioms, commonly used expressions or commonly used patterns that are well understood for people that have used that language for a while. Short circuiting is one of those things, right? It's a programming language idiom that you just have to know about eventually, and once you know about it, then then you understand its meaning. Just like if you're learning a new language and you hear a new idiom, whoa, I have no idea what that means. And so instead of translating it, you transliterate it. You define what that idiom means in the context of that language, and then you understand it going forward. And so it's just one of those idioms that you have to learn, right? Okay. Any questions so far? No? Okay. One last thing, and then we'll do an exercise really quick. So in both languages, you can use numerical comparison operators to compare single characters. But single quotes denote single characters. So if my initial is lowercase c or it's equal to uppercase c, then do something, right? You can use this like in your lab tomorrow. There's code in there that prompts the user to compute their taxes. They ask, do you have any kids? Yes or no. And somebody types Y or capital Y. We should accept both of those as valid yes answers. Anything else is no. And so to check for that, you can just use the non-numeric equality operators, equals, equals. And why can you do that? Because of the ASCII text table. Single characters are just numbers, right? The capital C, does anybody know what that is off the top of their head? 65, 66, 67, right? So this has a value of 67 in the ASCII text table. Lowercase c has a value of 99, I think. You'd have to look it up. It doesn't really matter. Who cares, right? Because you're using this equality operator here. You're actually just comparing it to the value in the ASCII text table. It is still a numerical comparison, right? In neither language can you use this for full strings. We'll look at a solution much later on for doing string stuff, right? All right. So, yeah, go ahead.
This has nothing to do with the if statements, but when you're compiling something that needs the math library, does it matter which order the?
Unfortunately, it does. The -lm thing. So on most systems, I don't know if I'm lying or not, but most systems you put it first. Some systems it doesn't matter, but if you're using the CS50 IDE like I am here, that's an Ubuntu distribution, and they require it to be last. So let's go ahead and take a look at what we're talking about here.
Yeah, I was stuck on that for.
Yeah, it should be in the handout, isn't it?
We were doing like the LM in the middle of it, not at the end.
Right.
The handouts have it first.
Well, there should be like, in some systems it's like this, but on the CS50 IDE it's like this, or not? Okay, let's go ahead and, I don't know, double y is equal to square root of a, right? And I don't know if I've, yeah, there we go. Okay, so here you can see undefined reference to square root. And so I'll go -lm, and now it's fine with that. Although the warnings are still there, it's still compiled, right? and it still ran. Right? Oops. Kill that. We'll talk about how to kill runaway programs like that in a bit here. But otherwise, if you tried it with, say, LM, if you are on the CSE server, you would go LM like this, and it's still going to be undefined reference to square root. So because we're on Ubuntu here, host, I don't know, uname? Yeah, well, Linux, but it is Ubuntu Linux here. And so they're going to require you to put it at the end. Yep. Sometimes you can get away without that library at all. For example, like square root of 2 or square root of 4, it'll do the compiler might do the math for you if it's just a constant expression, and then not even bring in and link in the library, because it's a calculator. You could do the calculating math there, right? Yeah. All right, so let's do a really quick exercise here. Let's write a program that reads in a decibel level from the user, either interactively prompting for input or as command line arguments. We can go one way or the other, and gives a description, a user description of that sound level. So 0 to 60 is going to be quiet. 61 to 70 is conversational. By the way, can you have negative decibel levels? Decibel levels are differences in air pressure. So I guess you could look at it the opposite way, but that doesn't make any sense. Decibel levels are, our perception of hearing. And if there's no noise, right, if there's no compression, sound waves or whatever in our atmosphere, then it's 0. You can't have, I guess you could argue you could have noise canceling headphones, right? But that's not a negative decibel level. It doesn't play negatively quiet music. It plays opposite amplitude to cancel the sound waves out from each other. So it doesn't work like that, right? So let's write a program to do this, okay? I'm just going to go ahead and reuse my demo code here. There was a question online from last week that I didn't see because they put it in the live feed. The question was, why do some mains end with a return 0? That's an exit code. Like when we go like error, you didn't give me enough input, so exit 1, I'm giving an error code of 1. The program ended in an error, and that error type was 1. Well, you can actually output, or you can exit with an error code of 2. Something different happened. An error code of 3 or 4 or 5, and then you can tell what kind of error occurred. With 0, 0 means no error. Right? False. Nope, there was no error. Right? And so that's why it ends with a return 0 here. It comes into effect here with the return value that we'll get to when we get to functions. Yeah?
Can you chain programs together using
From the command line, yep. So more demo.c, chain it, pipe it into grep main grep, I don't know, sort. You know what? No. More etc password. Here are all the users on the system. Of course, this is a CS50 IDE, so they're all just like fake accounts here. What I could do is I could run that through grep, which is GNU's regular expression. I want to find all the users that begin with an S, or that are kind of like sys, right? There they all are. But then I want to sort them. Sort, not wort. Right? And then I just want the unique ones. Unique. Right? Well, they're all unique, right? Because all users are unique. But you can chain them all together. You can pipe them. You can take the output for one program and give it as an input for another program, and then chain them as many times as you want, bringing together all these Unix utilities and doing something extremely powerful, all from the command line with just one line of code. Right? So yes, that's why. And then you can echo. What was the last output value? Nope. Okay, just bash. All right. You can actually get that exit code, but I forget how to do it off the top of my head. Right? Sorry. Anyway, back to our simple exercise here. Do we want to prompt or do we want to use command line arguments? Prompt, okay, so printf. Prompting means we're going to cue them for an input. Please enter a decibel level. And then we'll read in that decibel level. Oops. Should it be an integer, decibel, or should it be a double? Double? Okay, why?
Because we're going all the way to 100 or
195 and above, I don't know what that means. Negative values, I don't know what that means. But certainly you can have 50.25 decibels, right? So you're at anybody at the game on Saturday? No, no? All right, they have the decibel level, right? Especially when they tried to screw up their plays, and were they 105.4 decibels or something? Did they have decimals there? Yeah? They usually do. Okay, so I think we have an argument here to use doubles, right? And we're going to use a scanf to read in that double. %lf is our placeholder, and then we'll read in decibel. I think I spelled it correctly, but oh well. Now, is that correct? Let's find out.
and you need the
Yep, it's finding something wrong here, right? Don't forget your ampersand. Again, for now, magic. Okay? All right. If it's 0 to 60, it's quiet. How do I do something like that? If the decibel level is between 0 decibel and 60, then we'll output printf quiet. Yeah, I'm going to have to split it, right? And I only know that if I use the proper linting tool, right? So if it's between 0 and decibel is less than or equal to 60, right? 60 and then above, I didn't put in like what happens at 60.5. Right? I don't know, what happens at 60.5?
It's greater than
conversation.
Conversational? But we said 61 to 70, right? So, and 0 to 60 is quiet. So by allowing us to come up with, or allowing us to use a double here, what happens in those intervals there? This is not a very well specified program, right? From this, I would interpret, oh, well, maybe they only meant to enter integers and will reject all input that is not an integer, right? Or maybe they just meant that, well, 61 and up is conversational, and so 60.5, that should be quiet, right? Or maybe, no, maybe that's not what they meant. Maybe they meant that up to 60, but not including anything beyond that is quiet, or whatever, right? These are specifications that are incomplete. At which point we would have to go back to the people that told us to write this program and say, what do you do in this situation? You didn't tell me, because that's what program specification elicitation is all about. Elicitation is just a fancy word for eliciting your feedback. Well, what should happen when the user has 60.5? Is that quiet or is that conversational? You have to have that dialogue going back and forth with whoever told you to design the program, right? The stakeholders or whatever. And that's requirements elicitation. Well, what happens in this situation? What should happen in this situation, right? These are not well specified parameters here. So let's go ahead and assume that we went back and talked to them and they said, oh, well, yeah, up to 61 should be quiet, or up to 60, but beyond that, it should be conversational. Right? So we'll only go up to 60 here. If it's beyond 60, then it's going to be conversational. So else if, what is it? 60 is strictly less than decibel, and decibel is less than or equal to, what's the next cutoff? 110? 110. There we go. And by the way, if we ever have anything that is not prescribed in our documents, you can take an educated guess maybe, or you can post on Piazza. You wrote some bad material here. What do we do in this situation, right? Yeah.
I was just gonna say, I thought I read something, or saw one of the videos that like a good style is to put like the variable before the number.
I would, yeah, absolutely. That if you've got something like, where is it? Yeah, here. So this is bad style. 0 equals to A. In this case, though, I would say that that's just a guideline, right? I'd say that this case we're looking at a range, and if you've got a range, then that's a very good argument to not necessarily, go with that style. This looks a little bit more natural. Right? But is all of this necessary on line 2 here, or on line 14, excuse me? So think about how an if-else statement works. So if it's between 0 and 60, then it'll output quiet. If it's not between 0 and 60, it'll go on to the next statement. What do we know at that point on line 14?
It's already
Bigger than 6.
It's already bigger than 60. Or it could be negative, but we'll take care of that in a moment here. So, do I really need this check right here? 60 is less than or strictly less than decibel? Nope. I wouldn't be here if that weren't already true. So I don't need that extra check. And that's a little bit more readable code. And in this case, I would put decibel first and then the value next. Continuing with this, else if decibel is less than or equals, again, applying the same trick here. 194, or no, what was it? 110 is loud. Oh, wait, quiet. Sorry. Quiet, conversational. It should be 70. There we go. Thank you. 110 is loud. And then else if decibel, what was the next cutoff? 194. Then printf, what was it, dangerous? Else. Okay. Unknown, right? Again, that's one of those specification things. Nobody told us what to print if none of those applied, so printf unknown volume level. Great. If it compiles, we're done, right? Oh, it compiles. Now, should I test it? Probably want to test it. Now, what I'm about to do is called ad hoc testing. I'm just going to test it on a few values from the command line. It's not a formal testing framework. Instead, what a formal testing framework would involve is writing tests like you're going to do in your lab tomorrow, so that it's repeatable. So that, there's something's not passing here. You can go back, change your code, run all those tests again to make sure that change it might have fixed what was failing, but now it might have broken something else. And only if you've written this automated test suite that you can run with a click of a button or with a run of a command, will you know whether or not it's working all the time. Question? No. There was or not? Okay. All right, so help me. How should I test this rigorously? I should certainly give it something that's quiet, right? 30? Quiet, okay. I should probably give it something at the edge, right? 60, I would expect it to be quiet. Oops. 60, all right, there we go. Test it at the other end of the range. 0 should be quiet. Doesn't get any quieter than that. Right? Actually, if it's 0, then the tinnitus kicks in and you can hear a nice high-pitched squeal, at least if you have tinnitus, right? All right, so, I don't know, 65. Oops. 65, yeah, good. Let's go 65.5. Conversational, it still works. What about 70? What would you expect? Still conversational, okay. 70.00001. Loud? Good. 5. Quiet. Why? 5 is quiet? Well, yeah, 5 is quiet, I guess. 500. Let's go with that. 500. Still quiet. Yeah, that's probably fatal, actually.
It's reading the F, right? And then
What it's doing is it's not reading anything, right? It sees the F. F's not any number I ever heard of. So what have I parsed up to this point? Nothing. And what is the numerical value of nothing? 0. Right? So maybe that's something that we want to take care of. Who knows? We're not going to get into that yet. What else should I be testing though? The actual 500, right? Unknown volume level. Okay. -10. Unknown. Oops. -10. Conversational. So there's a bug, right? And again, I'm doing ad hoc testing here. I had like a dozen tests that I just did that I know are correct. But now I've discovered a bug. If I go back and change my code, I have to go through every single one of those tests manually yet again to make sure that I didn't break anything with my changes. Whereas if I had written code to automatically test my other code, then I can just compile and run automatically every single time. And I get a nice little report. I could have hundreds of test cases. And instead of running each one after the other, one after the other, one after the other, I just write a program to run all those test cases for me and say, you passed 99% of them. Right? It's this one that you have to focus on. Here's information on how it's failing and why it's, not why it's failing, because that's you going back to look at your code. So let's walk through this code. -10. Is it between 0 and 60? Nope. So next. Is it less than 70? Yep. And that's why conversational ends up being true here. So let's rethink our order. Remember, order matters in if-else statements. The first one that evaluates to true is the one that gets executed. And in this case, it's ending up being the last one instead. So let's take care of that edge case first. If decibel is less than 0, printf, you cannot have negative decibel sound. Right? There we go. Else if, now I can get rid of that first check, right? And now, because I'm doing ad hoc testing, I'm going to have to go back and redo all those dozens of tests, right? Nope, scrap that idea immediately, and let's start automating things. Write a program to test programs. Now, it could be that your program is wrong and your tests are wrong, but they agree, right? 2 wrongs make a right, apparently, right? That's very, very, very unlikely. It could be that your program is right, but your test is wrong, in which case you got a false positive, right? Your tests are saying that there is a bug in your program, but the tests are wrong. They're false. They're positively saying that there is a bug, but they're false. You could have a test that passes, but the code is wrong, or what do I want to say? It doesn't catch a bug over here because you don't have enough tests to test all possible situations, right? In which case you have a false negative. It says, no, there's no bugs over there. It looks clean to me, right? That's also a false report. Right? It's a false negative in that case. You want to make sure that everything is correct. Your code is correct and all your tests are correct. And with high probability, if you've got 100 tests testifying to the fact that your code seems to pass all these tests, you have a high degree of certainty that your code is correct. You'll never have 100%, because for 100% correctness, you need a mathematical proof. And there's really no way to do that. Right? There's some ways to do that, but not always. And certainly you wouldn't bother with something as trivial as this. Okay? Questions on conditionals? Do you want this code in the notes or not?
Sure.
Okay.
Access those the notes that you write.
Yeah. I push it out to GitHub. GitHub, me, Computer Science 1. The notes for the main section are immediately here. Oh, you go to your semester. The notes for the main section are right here, and then the honors notes are right here. I can go ahead and post that into, no, I can't post that into Piazza, that's on a different computer. So I'll post it later on Piazza if you send me a reminder. But, yep. Okay. So there, you have that in your code, in the notes at least. Okay. Really quickly here, just to not forget about Java here. Oops, that's not what I wanted. What's the only difference? Instead of printf, you have system.out.printf, or println, or just print, etc. That takes care of all those. So, okay. Find and replace system.out with system.out.printf. Place all those. All right, there we go. That takes care of 99% of the entire program, right? I don't have scanf though in Java. What do I have instead? System.in, and so I would need to create a scanner around that. Scanner, S is equal to new scanner, reading from system.in, the standard input. There we go. And then I can read in the next decibel. I can read in the next double. There we go. And by the way, it automatically imported it up here for me, java.util.scanner. And
why do you have to close the scanners?
that's a good question. So the standard input, the standard output, and the standard error are all technically files. If you open up a file, you need to make sure that you close the file. Now, if you don't close a file, it could end up being corrupted. In this case, it's just the standard input. So who cares when your program, I could mash the keyboard here and enter in 10 space and then a million Fs or whatever. And ultimately it would, you're only interested in the first number. That million Fs that's still in the buffer, which is a file, is still there. Do you really care about it or not? Well, if you care about it, then you need to close it to make sure that it's closed properly. In this case, though, standard input, the operating system will take care of it for you. Now, when we get to file I/O, it is absolutely important to close the file before you're done with your program. If you don't, there's 99 times out of 100, the operating system will save you from yourself, but it's that 1% of the time that you don't close a file. It's basically like closing a program without a Word document. You write 50-page essay, and you close it. What does it ask you? Are you sure? Do you want to save before you close? Right? It saves you from yourself. In programming, it's not going to save you from yourself. I wrote 50 pages to this file, but I didn't save it. I didn't close the file. Okay, fine. You didn't really want that 50-page essay. Let's go ahead and throw that out. Right? So yes, it will. It should be closed technically, but it's not necessary in this case because we're reading from the standard input. Let's run it. I'm not going to test everything again, but 100 should give me a loud, right? Yeah, loud. Okay. All right. No questions online. All right. Then let me go ahead and get rid of that. And let me start on the next topic here. There we go. Yeah, go ahead. Oh, okay. There. Bear with me while I reopen them. And go down to the bottom. Java version. There you go. It'll be out there when I have to commit it and push it. So while I'm eating my lunch here, that'll happen at some point. All right. All right, Markdown. Open new window, bring it over here. Oops. And zoom in. So loops are the other basic control flow kind of mechanism in a programming language. Whereas with conditionals, you decide to do something or not, or you decide to do A or B. A loop allows you to do something over and over and over again for as many times as it takes. Sometimes you have a runaway loop, right? You do something over and over and over and over, and you never stop. What is that called? An infinite loop, right? We don't generally want that, but there are some situations in which we do want an infinite loop, right? My computer is in an infinite loop right now. It's called a pull loop, right? It's always on, waiting for me to type something, or waiting for me to move the mouse, or waiting for basically input, right? It is sitting there in an infinite loop waiting for input, but we won't do that with our programs just yet. But there are 4 basic elements to a loop control structure. If you're going to repeat something over and over and over again, you have to have a starting point. That's an initialization statement. That's where the loop starts. Then you need to determine, should I continue? Right? Should I continue this loop one more time, or should I stop and move on with the rest of the program? That's a continuation condition. How long should the loop continue, or when should it stop? That's the opposite. The negation of that is the termination condition. Okay, no, I do not want to execute this loop anymore, so jump out of it and continue with the rest of the program. Then the third part is the increment or update. So if you're doing something over and over and over again, and you have a termination condition, you have to make progress towards that termination condition. If you're not making any progress towards that termination condition, you're caught in an infinite loop. And maybe that's what you want, but 99 times out of 100, that's not what you want. So you have to make progress towards the end of the loop. And then finally, you have the loop body. Right? What are you actually doing? Because you can go into a loop, do nothing, continue doing nothing, continue doing nothing, do nothing, do nothing, do nothing, right? What you're actually doing inside the loop is called the loop body. That's a piece of code that executes for every iteration. An iteration is one cycle of the loop, okay? All right, you've probably seen them before. So we'll only look at the 2 basic loops here. First of all, you have 4 loops in both languages. It uses the keyword, what do you think? 4, right? F-O-R, right? All 3 elements are on the same line, right? The initialization, continuation, and increment. So we're just going to look at a very, very, very simple version of this. For int I equals 0, let me go ahead and use this. Actually, no, I'm going to start at 1. I is less than or equal to 10, I plus plus. And I will print f, I is equal to %d, and the line, and print I. There it is. What does this piece of code do? So there is the initialization statement. Where do we start the loop? We start at I being 1. This is the continuation condition. While this evaluates to true, continue the loop. So in other words, while I is less than or equal to 10, we will increment this loop at least one more time. Here is the increment condition, I plus plus. That's new syntax, all right? Plus plus, what do you think that means? Add 1 to the variable I, right? That's just a shorthand. What I could have done instead is I could have written I is equal to I plus 1. But that's like, what? Oh, say what?
Is there plus equals 2?
Yeah, that's a compound, or you could write it as plus equals 1. But you're just going to go up by 1. There's a shorthand here, plus plus. That's called syntactic sugar. So it's you don't need it, right? Sugar, you don't need it, right? But you want it, right? It's nice to have, right? And it makes the a language richer. If there is a shortcut way of doing things, if there is a more compact way of writing the same code, the common code that you write over and over and over again all the time, that makes it a little bit more expressive, right? We don't need, 20 different adjectives for cold, right? We just need one adjective for cold, right? But it makes our language richer to have all of these different adjectives. Likewise, with a programming language, it makes it richer, more expressive, easier to use if you have syntactic sugar like this, okay? What does it ultimately print, though? each value of I, and so what values of I are going to be printed here in this case? 1 to 10. All right. Why? Because we start at 1. Each time we go into this loop, it says, okay, well, 1 is less than or equal to 10, so let's go ahead and execute this, and it ends up printing 1. At the end of the loop, this increment occurs, and so 1 becomes now 2. And so it goes back up to the top of the loop and says, I is less than or equal to 10 still, because 2 is less than or equal to 10. So go ahead and execute this loop, print out 2, and at the end of the loop, increment this I++. Now it becomes 3, then 4, then 5, then 6, ... until it gets down to 10. Right? At which point 10 is less than or equal to 10. Is that true? Yes. So it prints it out, and then at the end of the loop, 10 becomes 11, and I've run out of fingers now. Is 11 less than or equal to 10? Nope. And so we break out of the for loop, and we can print done. Right? Now, what value does I have at the end of that loop? Oops. No semicolon.
What value does I have?
Yeah, what value does I have after this is all done? It was 11 technically, right? On the last iteration, it has 10, but then it goes up to 11, breaking us out of that for loop, and then printing done. Let's try to print I to see that it has 11. %d, and then I. So we think it's 11, right? Won't even compile, right? Because of scoping, right? I is undeclared. I don't know what you're talking about. Where does the variable I exist? It starts before I create it before the loop, right? It exists on each iteration of the loop, but after the loop is done, it no longer exists. Right? I can change this by creating it outside the loop. Right? Getting rid of that, and now it will exist after the loop. What value will it have? 11. Right? That's how we got out of that loop. So which is better? This version, in which I create the variable, it exists before the loop, it exists during the loop, and it exists after the loop. Or the first version, where it only exists for the loop. This one? Or
It depends on what you're doing, right?
okay, so it depends on what you're doing. I like that answer. And if you have many for loops, maybe you want to reuse this variable, right? Both are good arguments for one, for the other. Yeah, sure, you just don't want to declare yet another variable. But here's the ultimate kicker to both of those arguments. Always make sure that you are limiting the scope of everything that you possibly can, right? The most evil thing that you can do are declaring global variables. So let me come up here, int I. Because you might, let's take that logic and let's take it up a notch and take it up to 11, right? Where 50 different functions probably will need a variable I to do this. So I'm just going to declare it as a global variable, global I, right? Now I never need to declare that I at all. I can just use this, and then in another function I can use that I, and in another function I can use that I. I never have to declare the variable I again, right? Now, hopefully that's clear that I'm taking it too far, right? I've grown mad with power, and I've created this variable with a global scope. Globals are evil, right? You might see that expression eventually, right? Globals are evil. It's just really, really bad practice. And if globals are evil, why are they evil? It's because you are expanding the scope of this one variable I. You're doing something called polluting the namespace. Nobody can ever create their own variable named I. Now my code and your code that uses a local variable I are incompatible. They won't even compile together anymore, right? They introduce unpredictability. If one function has if these two different functions can see this one variable, then they can step on each other's toes. We want to make sure that to segregate those two out into their own scope. You have your variable I, they have their variable I, and then they never, step on each other's toes. So ultimately, what you're trying to do is you're trying to limit the scope as much as possible. Now let's just jump into the main here, int I. I'm not going to do this. Right? Int I, now if I do this, do it like this, where it exists for the entire function, right? That's not as bad as creating a global evil variable, but you're stepping too close to the evil line, whatever that evil line happens to be. Whereas if I had done it like this, int I, now this loop, only this loop, has access to that variable. It doesn't exist outside that variable. And if I have, or that loop, excuse me. And if I have another for loop, I'll go ahead and create a variable for that for loop, right? And start it at 2 and go up by increments of 2, right? And up to 100 instead, right? It owns its own variable. The first loop owns its own variable, and they don't step on each other's toes, right? Because otherwise, if it was globally, or not globally, but if it is declared over here, it exists after the loop. What value did it have? I was equal to 11, right? Does that have any bearing on the subsequent loop at all? No. What if I forgot to declare that, or to initialize it? You don't have to have a statement. Then I just take whatever value was left over, right? So in general, you want to limit the scope of variables as much as possible. And in both languages, that's achieved by using this syntax right here. By the way, old school C, before 1989, you couldn't even do something like this. You had to do something like on a line 11, where you create it. In fact, really, really old school C, we're talking 1978, you could not declare variables down here. All variables had to be declared up here at the beginning of a function, right? Let me show you. I'll go ahead and get rid of this, and create int, or double x is equal to 3.14, right? Let me show you what it was like to program in 1978. I'm not that old, by the way. I didn't exist in 1978. GCC demo. So 2021, this is perfectly fine. Well, not here, I guess, sorry. Let me go ahead and get rid of this. 2021, all this code is perfectly fine. If I go into the time machine and go way back to 1978 and do it in pedantic mode. Oh, come on, really? Okay, apparently pedantic mode is not supported. Okay. Version. How do I do versions? C89? Nope. I can't do it off the top of my... Oh, STD. STD equals C89. There we go. Right? And I'm not allowed to do that in 1989. I'm not allowed to do this in 1978. So, ANSI. There you go. Oh no, what? ANSI? C. ANSI? Nope, I don't know what. I forget. It doesn't even matter. Who cares about a 1978 standard? You care if you are doing something with hardware that has a very low level support and hasn't been updated in 20, 30, 40 years, right? Legacy systems. Okay. It doesn't even support stuff that old? Maybe not. I don't know. But in any case, the lesson to take away for today is to make sure that you are scoping your variables down as little as possible. In all instances, you'll be able to use this type of for loop in both languages on pretty much any system. Right? Now again, the only problem here is system.out.println. And it's the exact same syntax, system, in both languages. Right? 1 through 10. Same exact behavior in both languages. All right? Any questions? No? Okay. Well, if this is all old hat to many of you, don't worry. We'll get into more newer, shinier stuff as we move along here. But we do have to get through the basics first. All right.